Hey, what's going on? It's Justin Dickmeyer from EngineerInTrainingMA.com, and in this video we will review t-distributions. According to the central limit theorem, the sampling distribution of a statistic will follow a normal distribution as long as the sample size is sufficiently large. Therefore, when we know the standard deviation of the population, we can compute a z-score and use the normal distribution tables to evaluate probabilities with the sample mean. Now, we discussed normal distribution in the previous review. However, sometimes sample sizes are small, and often we do not know the standard deviation of the population. So when either of these problems occur, we can rely on the distribution of the t-score given by the equation sample mean minus the population mean divided by the sample standard deviation divided by the square root of the number of data points. Now, what this is telling us is that if we have a normally or near normal distribution of data points, but we have a small sample, and we don't know the standard deviation, then we can use the t-score to approximate probabilities based off the given data. Now, the form of the t-distribution is determined by the degrees of freedom. The degrees of freedom, also notated as df, the degrees of freedom refers to the number of independent observations in a set of data. So when estimating a mean score, the degrees of freedom is equal to the sample size n minus 1. Equal to the sample size minus 1. So for example, the distribution of a t-score from samples of a size 8 would be described by a t-distribution having 8 minus 1, or 7 degrees of freedom. Now, the t-distribution has the following properties. First, the mean of the distribution is equal to 0. The mean of distribution is equal to 0. Secondly, the variance is equal to v divided by v minus 2, where v is the degree of freedom and is also greater than 2. So the variance is equal to v divided by v minus 2. Also, the variance is always greater than 1. Although if the degrees of freedom are high, it's very close to 1, but the variance is always greater than 1. Now, once again, we need to reiterate that we're dealing with nearly normal or normal distributions, and the only reason we're not using the normal distribution data or the z-score is because we have a small sample size or don't have the standard deviation of the population as a whole. So let's run through and clarify the process of using t-distributions. So as we mentioned, when a sample of size n is drawn from a larger population, this is our sample, and this is our population. Now, when a sample is pulled from a larger population, and we know the sample size, we know the sample mean, and we know the sample standard deviation, then we can convert that sample mean into a t-score. We can convert this sample mean into a t-score using the equation sample mean minus the population mean divided by the sample standard deviation divided by the square root of the sample size. Now once we get this t-score, once this t-score is defined, we can go then to the t-distribution tables. Now once we're in the t-distribution tables, we're going to see something like this. The table is going to be fairly large. In the upper left corner, you're going to see DF, or degrees of freedom. There are going to be whole numbers going down the first column, 1, 2, 3, 4, and so on. And then this upper row, first row, is going to be something like 0.05, 0.1, 0.15, 0.2, etc. And this is known as the tell probabilities, and I'll explain that here in a minute. But within this table now are our t-scores. So whatever our value is, we need to come into this t-distribution table and find it. So we do that by knowing the degrees of freedom, which again is n-1, and our t-score. So once we have these two, we can determine. Now the t-score is associated with a unique cumulative probability known as the tell probability. This cumulative probability represents the likelihood of finding a sample mean that is less than or equal to the sample mean of our data, given a random sample size of n. So this tell probability represents the likelihood, or the probability, of finding a sample mean less than or equal to the mean of the sample given a random sample of size n. So let's look at a quick example here, illustrate this. Let's say that a certain company manufactures a part. So they manufacture a wide, huge population of parts, and they say that the mean life cycle of this part is 300 days. So the mean of the population is 300 days. Now a researcher comes in and grabs out a small sample of these parts, and that the sample size is 15. So they grab 15 samples. They test the samples and find that the mean life cycle of those samples was 290 days, with a standard deviation of 50 days. So the researcher wants to know, if the company's claim were true, what is the probability that 15 randomly selected parts would have an average life of no more than 290 days? So we're looking for X bar is no more than 290 days. So we need to find the tell probability, or the upper number in the t-distribution tables. So the first thing to do is just let's determine the degrees of freedom, which is n-1, which is our sample size minus 1, which is equal to 14. Now let's find a t-score. We take our sample mean, which is 290 days, minus the population mean, which is 300 days, divided by the sample standard deviation, divided by the square root of the sample size. And we find that we got 0.775, and that comes out to negative, but due to symmetry we can ignore that negative, so 0.775. So now we take that back to the t-distribution tables, and again it's going to be, I can't show you the guys on the screen, but it's going to be something like this, and we want to go down the first column until we find the 14 that represents our sample here, our degrees of freedom in our sample. And then we just go horizontally until we find 0.775, and that's our t-score. Now we need to go straight up to our tell probability, which is approximately 0.22. So what that tells us is that if the company's claim is true, that the part life is 300 days, then there is a 22% chance that the average part life for 15 randomly selected parts would be less than or equal to 290 days. So 22% chance that the sample mean of 15 parts would be no more than 290 days. So that's all I got, guys. That's a quick review of t-distributions. I hope that clarifies a little bit, or at least get you guys thinking again about t-distributions and how they relate to normal distributions. It's essentially the same. We're dealing with normally distributed data, but we're dealing with small sample sizes and not a big population. So using the t-score and the t-distribution tables, then we can find much data that we may come upon on the exam. So anyways, if you guys have any questions, head on over to EngineerInTrainingMA.com. Shoot me some feedback, some suggestions, or whatnot. Just call, send something and say hi. Either way, we'll be talking soon. All right, take care.